chairs to make sure you had time to gaze upon its wonder and glory. I will summarize shortly. Okay, we're going to start. It's the last session. I have the first 30 minutes. Wonder and gaze on the note well. If you haven't ever read it, take time. It's a fascinating document. Enjoy. How's my voice? Too high, too low, just right? Mama bear, Papa bear, baby bear? Okay. So please look at all the documents there. If you want to know the details, please read. I left it up there for 5 minutes. If you want to snap it, it's on the website, but do take a look at it. Okay, what are we doing today? Well, I'm trying to get through a report on the interims in case you missed it into flow spec. What is our purpose? Come to some basic flow spec that adds user ordering. That's what the working group wanted. The flow spec V2 that we had was wonderful, correct, but too much for an implementer to do all at once and fulfill our requirements of 2 implementations. Once we do mine, we'll go through some other ones. Nan, I hope, will appear sometime. He has the first one for flow spec. Hopefully Yuja will be there remotely. I haven't seen her in the chat window. Gee, if you see her, make sure to say hi. Yeah. And Linda's going to go through the a redirect example for 5G. Okay, then we're going to go through Anchor. Anchor's here. He's going to do through deterministic route redistribution. And then we're going to have an SD-WAN presentation and V4 and V6. And I think that Guyan is remote this week. So, and Changfen didn't get his visa. So that's our agenda. Any bashing of me, bashing of IDR, more bashing? Okay, let's get the next one up. Well, that's interesting.
Yeah, no problem.
Did they reset it?
No problem.
Yeah, okay, I gotta turn off my volume again. Okay, no problem.
Share slides. I can have that.
Yeah, we should have that. Okay, something happens, it's all yours. Okay, flow spec. This is the short, I hope I can do this quickly, review, but there's a lot of slides. So, just in case you missed it, what we were doing last time, I announced we would go through goals of trying to break this huge spec into 4 parts. First, we want a minimal subset. The purpose is the smallest possible delta to get to user ordering. That's V1 plus user ordering, nothing else. Okay? Then we were going to add the intellectual property it takes to do other things. Dependency between filters. Still got a lot of work to do. We're not going to move that one ahead until we do the discussions for that. The next one is new actions. We currently have extended community actions, and we're going to continue in V2 to have extended community actions. We're also going to have wide communities. I'm so glad to see you. Not, no, I was just, and we're going to look at action change. But again, chunks of work. We're going to do that in the future. What we're trying to do now is the basic, and then we'll go for the non-IP filters, such as L2 or MPLS or FLC, or maybe even something else. We could use it for up-and-coming things that use a firewall. Remember, FlowSpec is a firewall specification. Okay, so what do the drafts do? What did I put out these drafts? Well, the FlowSpec HARES vSpec IP basic is your minimal subset. It's got all the boilerplate from the original FlowSpec V2. You can say, I don't like the boilerplate, but that's where it came from. It's the base draft. What does Hare's Flow Spec V2 more filters. It's basically the dependency filter work that we're going to do. What we decide to do about filters, it's got a proposal, it's a straw man, we can beat it up, and a template. All the rest about the drafts that are in there, they're going to go into individual drafts. The same is true of the Hare's Flow Spec V2 more IP actions. It has the action chains. Do you set DSCP flag and then copy and then redirect? What happens if it breaks down and you don't set the DSCP marking? And a template. Now that one's not updated with the template at this point, but we've got a lot to learn. So what happens if you had a V1 specification? Several of you had it. The reason we're taking this group approach is I've got 25 drafts that people wanted to specify flow spec in V1 or V2. And I'm trying to give the working group, as the chair handling this, a place to go, an architecture, templates, and then have at it. Same deployment requirements. So what happens if you have a V1? Well, if you've deployed it, give me both a V1 and a V2 spec. Might be the same as just adding, we're going to do the same thing. Might have to add more. If you have a question, come see me. I'll give you hints and templates. If you don't deploy, start with the V2, because the working group decided no more V1. We have a lot of drafts in the in-between that deal with redirect. I'm going to try to go through those in a moment. V2, use the templates if you're specifying more filters or actions. Okay, so what's new? What's sort of interesting? Well, something for us to think about is we have prefixes in there, and we have UDP, and we have things that go on a simple firewall. But maybe we want to tag it with other things. We tagged it in some actions with interfaces. Some people have requested colors. Some people have requested times, ASs. This is not a given, but this is thought work that is in there for you to start, well, is this going to fit my flow spec? That's one place we came back with the feedback. That's a new piece. Now, Jeff gave me a challenge, and Jeff, this is for you to see I can do this. He said, in the specification, we're going by types. L3 from V1, and then a new one that's L3 with all the new extended features like TTL, and we're going to number them. Jeff said, gee, Sue, can they be numbered from a global thing? So by default, it might just work for the first round. So I took that as a challenge. Never give me a challenge. You could number them either individually, like the tunnel component numbers were numbered in V2, or you could number them with a second number, like 131. So I've given you an example. Again, this is just work for discussing. Our base will only be our flow spec V1, nothing more. And that's what's under working group adoption call. Okay. Any questions so far? If you all got all of that, we can all go home quick, but I suspect maybe I ought to try to do the little bit more. How does it look when it's ordered? You have rules with match conditions. They have, each rule has a rule type, be it L3 V1, like our good flow spec V1, or extended with maybe TTL, maybe the SRv6 header in the IPv6 packet. I'll try that again. The SRv6 header, routing header in the v6 packet, or the NRPID in the v6 packet, or TTL, or something else. There's a payload filter proposed. Those are new. Okay, so you have a rule. A rule has an order. And this identifier is the old thing. The identifier was first a logging identifier, but that's what we thought was an error. We thought it really should be a filter dependency because you need to do it on the order. Right now in the basic, it's just 0. It's a placeholder, okay? And that's our decision for the first time is, can we buy off on 8 octets in case we need filter ordering? I want to do 1, 2, skip a few to 5. That's feedback we need. Then there's a type. These are the types. Notice the basic filter rules, but then we're starting to work on the extended IP filter rules, others. We could put SavNet filters in there, okay? When you start breaking it down by type, it becomes within an LRI several streams. We think that's the best way to do the additions right now. Do give us feedback. We're adopting the IP basic as an adoption, even though the work is already been approved for the working group, but I wanted to go through and ask the question again. If some of these don't work out, we can change it still till we get to implementations. But the implementers need some place. Now.
Hi, Sue. Jeff is in the queue. Do you want to?
Do you want to take your comment now, Jeff?
Yeah, I think it's a relevant point. So back on slide 8, if you don't mind.
You're really loud.
Sorry, I'm going to be a little bit quieter. So back on slide 8.
You're still loud.
Back on slide 8. There we go.
10 slide, slide 8. 8. Maybe.
Go ahead, Jeff.
Not 18, 8.
8.
You would one
Slide
time?
8. On page 8.
Page 8. Go back.
Sorry, your slide numbers are not consistent. And the slide number with the different numberings of the components, there are two things that we're looking for there. The first thing we're looking for is, what are the components and how do they relate to each other? Because default flow spec rules are, we cascade and sort them based on component ID right now, this slide right here. So the challenge you have doing the default sort order is, what happens if things need to order themselves in a way that's natural for like DDoS, which is what FlowSpec v1 was about. So picking an easy example like TTL, which you have numbered as 14, if that was the number that we wanted to put stuff in, it means that stuff that is sorted on TTL is going to happen very late in the sort process. And certainly a user order can be used to bias that. Part of the exercise here is to say, well, what happens if we have a new thing and we want to insert it, for example? And if we go for an actual 1, 2, 3, 4 style numbering, we're not going to have any room to do that sort of thing. If we leave spaces, 10, 20, 30, 40 as an example, we have the ability to at least add stuff somewhat at the end or somewhere in the middle. So that's part of the reason we're looking at this, is to see what the default sort order could be if we were to sort of naturally put these things together. Like L2 probably sorts before L3. MPLS probably sorts somewhere between L2 and L3. Tunnel, does that sort in the middle? We'll figure that out. But if we don't leave any spaces, this means that as we add features later on, there's no place for it to go naturally without explicit user ordering.
Okay. Anything more, Jeff?
That's it.
Okay. So the important thing is this is our NRI top level. It breaks down then if you have V1 to order, this 0 for future filter dependency chain, and then the type. And then after that, it's V1. Yes.
Dhoni, one question, especially thinking from, we have a document in PC working group which is about L2 flow spec. And
So you copied the components.
yes, so
They aren't changing.
Yeah, so my main question was, how does the INA registry would look like, especially if you go one slide back? Uh, every one of them are getting where we had all the list of numbers, whichever that slide was. Yes, this one. Everyone is a separate registry here. Like, is that how? What's the registry design that we are thinking?
That's a point for discussion, first of all. Second, if they were, they all would have to be in different registries. The question is whether we start the default numbering as a global numbering and see how it goes. Okay?
I think that's going to work out for us as well. So yeah, but I'll continue to look. Thanks.
Okay. Ordering. Flow spec V2 and V1 are ships in the night. Rule 0 is permit all, and from there, this is DDoS, you restrict it further. The way to make it work with flow spec V1 by default is to put your flow spec V1 at the end at a single ordering. But the document also says you could put a configuration knob and put it in there if you're an intelligent user. You know, the guaranteed working is at the end, but if you want to put it in the middle because there's something special about your box or your application, okay. Now, the ordering within the user ordering is done by component number, which is why those components are important. By default, if you had a global component order, it would all just work together, except when you accept it. If you have the same user number and order number, which is what we have today in V1, it defines it by component. The component numbers 1 through 13. If it's the same component number, IP destination and IP destination, there are rules in V1 for ordering it within the component. We're not changing that. Okay? We're not changing V1's component or ordering. You just have the option of doing a user order before you do your component. Use one component number, 1, for all of it, for V1, and set your configuration that V1 stuff will do the same. It'll work the same as V1. So, okay, what do we think we can do for extend? So that's the basic one. That's what we're working. That's what's under working group adoption call to say, did we get it right? The buy-off is the format and the dependency chain. Beyond that, we're trying to work toward the future with people who are proposing new filters. So the new filters, in order not to impact V1, are in a new NLRI type 2, and they're extended filters, and they're ordered. Now, there is a version on top so we can keep ordering it. Maybe you get TTL and SID header and LRP and payload in the first string of the specification. Well, the version could help you say that's what I have. Whether it should be user-based or whether it should be standards-based, there's a lot of discussion there. This is future work. People who are in the new filter business need to contribute. Okay, L3 is one of those components I already went through. We've gone through that with Jeff. And these are various delay, pieces. Prefix list orders. There are a couple ways you could do it. You could have rule number 1 and several components where they're all at the same user order and they're unique V1 components. No problem, you can do that now. You could have it 2. We could have something that looks more directly like a prefix component list where you had it more complex. Not really in there, but possible. Okay. But gone through that thanks to Jeff's help. Now, here's the filter dependencies. Again, I'm introducing the things that are coming in the future and why we have those 8 octets. Let's say you have today, you have a filter match. Okay, you got a destination. It matches, it goes to the second one, and then the action at the end says stop. It does some action, drop it or mark it, okay? You want, and then it would go on with 4. But you might want to say there's a dependency from 1 to 4. If I don't match 1, let's skip ahead, 1, 2, skip a few, go to 4, and have a dependency. Okay, that's possible. Then you'd skip to 4 and you might go then to 6. That might provide some better processing for some of the firewalls. I don't know. I'd like feedback. This is an idea that has been proposed. Jeff and I have looked at it. I've seen it. How does this work? Okay, same thing. Rule 1, match the location, match the destination port, match the source port, drop. Oh, I'm not going to match the location, in the SRv6 ID, go and see if I match the address. I don't do that, go on to something else. So it's a shortcut form. Doesn't really change how the components work, just talks about how your dependencies. And there have been many suggested dependencies in small groups. I need feedback. This is not something that's going to be done tomorrow, but those who are looking for extended filters need to work with this. Here's one from Nats. For example, of a modifying packet. Do you modify the packet as soon as the match occurs or not? This is filters and matches. That has to be done once we go beyond. Everything, if you've got a V1 implementation right now, in the V1 form, we're going to trust if you've got one working, you can get the next working. There's a lot of industry-defined de factos, and we're not going to mess with them, and we're not going to really specify it because we're going to have somebody broken. If you want to do that, let the chairs know. Okay, here's an example with the SRv6. I want a locator of SID1, a function of index, and an argument of 128.2.1.1. I also then want to match, after I match on that, to match NRP ID 10 in the hop by hop header, and then I want to match a source port, and the answer is drop. Okay, and you stop, and if you didn't do that, you might go on to the next match. Okay. Now, you can see for the folks who've been working on SAVNet how this might be good for a tactical short amount of SAVNet prefixes. That's a thought. We're still in discussions. Here's color. How many people know we've got a lot of color out there in our latest inventions, and they go to VRFs. Okay, so you match the VRF, and then you go to the address, and then you check the source port. And again, if you didn't come to a match or something failed, you can skip ahead. Deep packet inspection, that's coming out of our payload people. We'll match a destination port and then last the first payload and second payload. You will notice that Yuja's and co-authors' presentation has a flexible format. Is that what you want? Okay, there's a lot of, please give feedback or make a choice. Those who are proposing, it's up to you to help push the basics over the line and then get your draft implemented into implementations. Other data, let's say I want to have an interface group in AS 120 and then match the prefix. Okay, so that was filter change. Yes, AC.
AC Lindum Levin. This is just a quick question. I heard you say VRF. So you're going to mix the rules for multiple VRFs are all in one set of flow spec rules under the flow spec.
They're for multiple VRFs and
Okay.
multiple layers if we can get all of that sorted out. Yes, we're allowing for that innovation I have a lot of questions beyond the basics. I mean, there's a lot to do here, but there's a lot of drafts that keep coming up. So, okay, we've given you a framework. You can help us decide the solution for yours. You'll have to work on the common if you've got a draft in extended filters or adding new actions. But after that, it's, rinse, suds, repeat on your stuff. Okay, what about drafts on actions? What do they really do? Okay, here's a set of drafts, and some of them are old, some of them are old and used, like draft IETF, IDR, flow spec, redirect IP. Last one we had is 215, but it's referenced in RFC in a draft we sent up to the RFC, and it needs to get finalized. It's a V1 draft that's working fine, but we'll need a V2 forward. What does it do? It redirects to address and copy. What does the flow spec path correct and its V6 partner do? Draft IDF 0. IDR SR V6, I think, for path redirect, it puts it to a global ID. It also allows copy. What about TS flow spec? It looks for an SID tunnel to put it to. And again, then you start marking it with, and by the way, this is an error right here. That's not NRP. This is in capping. Flow spec and, excuse me, the NRP that's wrong is right here. This is only sending it to an IPsec tunnel. CATS ID folks are specifying flow spec, and they're saying somehow I'm going to put a CATS ID someplace in the packet. I said, that's cool. You tell me where it's going to go, and then that draft will go someplace before sitting. Shen says we want to compress stuff. And Peng says we want to put in an AP and ID and stitch and inherit. It's all really good, interesting work, but we've got to get through what happens when one of these things fail. What happens when you fail to traffic limit something? You've got DOS and you traffic limiter just doesn't work. Somehow it gives me back an error, or your DSCP marking doesn't work, or one of these redirects doesn't work. What do? Okay, well, that's really important because that's a failure mode. In Yang, when Jeff and I were working on ITS and Yang, it's all or nothing, or partial, or rollback. Right now, I sort of suggested the first place to do is all or nothing, but some of you may want best effort. Okay, action change, that's what that's about. If you have a default, maybe your default is stop if you have a problem. But for one, you want to keep going for best effort. Okay, those are lots of details. How is it going to be encoded? Well, we currently put it in several generic extended communities. We'll allow more. We're just going to define how they interact. Okay, it's working, don't break it. But I will warn you when you might break it yourself, okay? Here is the genitive transitive, and here's your global, okay? Again, the only thing you probably need to decide in there for action chains is what happens if it fails. What's your default? Therein is your stop, continue, conditional on failure. That's from Yang. Okay, what about putting it in the community path attribute? By the way, we miscalled this the wide community attribute. It's really a path community attribute, and one of the options is a large community. So that's the header. We could put an action dependency there. Thoughts? Ideas that were in the basic that people thought were good and were cycling back after 3 to 4 years. Now, who's used them? RPD has used them for match and set, and that got through working group last call before the problems with wide community brought it back to the wide community's definition in its RFC proposal form. In found some failures, so they both came back. But it's got match and set. The DetNet folks are giving us deterministic actions or map to TN flows. The SFC folks use an action that's an extended community that after you find a certain filter, you're going to pipe it to an SFC channel. Is channel the right way to say that, FSC folks? I think of it another channel, but, well, okay. Okay, what about non-IP? What have they been done? They filter on MPLS and EXP bits and pop and push. And I think the rest I'll let you read, but it's L2 and they mark in L2 the VLAN and the TIP. Okay, so we have a lot of things to decide. Your real question in all of this is whether you think the basics enough for the people who want to start. I think I did pretty good. The rest of it's just a whole lot of TBDs.
Okay, so Tony P. Juniper. All good. Do you expect all implementation to support the whole 7 yards of that? And how will you indicate who supports what?
I'm not hearing you. Closer to the mic. That
Sorry.
may be
Yeah,
my hearing aids are not
it
working
has
or-
been a long week. So do you expect all implementations to support these whole 7 yards?
No, absolutely not.
So how do we indicate who supports what? Because pushing the stuff, you know.
Okay, if you're doing V1 with order, that's your minimal subset, as it's stated in the
enough.
document. Anything else, when I got to the extended filters, I said, okay, we can put a version in there and say which one I'm supporting. Maybe you're in a network and you support 5 and you put the version number therein, and you agree on it in a set of places. And if you don't see that version number, you say, I can't do anything with it. I don't support all of these.
No, my my question is slightly different. I hear you, which is good. But you know, this is a lot of matching, and some of that can go pretty deep into the packet. And
Oh, yeah.
some implementations will basically say, look, I'm not supporting any L2 filtering. So how do I figure that out on a peer, you know, when I'm pushing the stuff onto them? Because partially programmed silicon is worse than no programmed silicon, possibly.
+1 on all of that. This is a work in progress, and all I'm
Okay.
doing is laying out how we're going to go forward.
Yeah, which is a fair answer. Yeah, okay.
And so for those people who want the extended filters, you got to help push the ball up the hill to get the rest done. We gave a complete spec earlier, and then it didn't get implemented. So now I want, if you're going to implement a feature and it's in one of these categories, help push that up and then propose the feature. Because we're 2 implementations. Let's go with, I can't see the thing. Jeff, did you have something? And then I go to Jeff Tensor, and then we'll cycle. And
Yes, so hopefully I'm not quite as loud right now.
Jeff, you're too loud. Back, just sort of move
Okay,
away.
I'll sit on the other side of the room. So to Tony's point, one of the discussions that we've had about these things is how do you actually figure out what devices in your network are capable of supporting individual features? And when some portion of your network doesn't support it, how do you make that aware, to the controllers that are creating these flow spec routes to get the job done? So it's a very valid point. We need to spend time on it. That's not on the current drafts right now, but it has been discussed.
Yes, and there, if I'm hearing you right, we have, we have some need for deciding about capability. For the basic set, you implement it all. It's V1 plus ordering. After that, we got to figure out where we go from there. If you think the V1 plus ordering needs some capabilities, now's the time to chime in. Jeff, your turn.
Jeff Centurion Media. My comment goes kind of to what I see as long as we keep filters on stuff that's unambiguous in data plane, we are okay. VRF has no representation in data plane whatsoever. So if you try to put in the filter something that needs to be derived and might be different from device to device, it's a recipe for disaster.
Right. We have to figure out, are we going to use a capability to figure out what goes from one to the other than the basic? If you sign up for the basic, you sign up for all of the V1 plus ordering.
Keep it to data plane.
Pardon?
Keep it to data plane, something that could be matched upon, not something that could be derived by.
I'm missing the point. Let me pick it up with you later on.
You can match an MPLS label, an IP address, on MAC address, on any layer 4 semantics of a packet. Keep it to something that is in the packet, could be looked up and matched upon. That's unambiguous. Something that's logically configured on a device is ambiguous across devices. It's a recipe for disaster.
Okay, I think I'm missing something, but I'll pick it up. It's my problem, not yours, I'm sure. Go ahead, Philip.
Philippe Bergeon. So on the comment just made just before about how to define what is capable, what a given system would support, I totally concur with what Jeff Haas was saying. Like, I mean, actually, we already have the problem in FlowSpec V1. You may actually not have all systems supporting all the match criteria, even in FlowSpec V1. And so it's a different problem how you advertise what you're capable or not. So I think it's a separate discussion. On the slide that you had before, I was intrigued by those complex go-to from entry 1 to entry 2 to maybe entry 5 and 6, because those are concepts that don't exist in most hardware implementation. So most systems actually perform a TCAM lookup, which is not going to allow you to do what is in this diagram. Like it is, so
Yes.
it's, yeah.
It is a future and not in many common hardware pieces.
Yeah.
It may be in other places, but the descriptions in some of the documents lead me toward this. If this is a verboten, ja, then we need to discuss that as a group. That's why it's out in this clear place. I don't have anything invested here
Yeah.
other than getting us at least on a direction.
Yeah, I was thinking if the main focus is switch router, this is
The main focus right now
Yeah.
is deciding if V1 order plus,
Sure.
the order byte plus zeros in the dependency area plus the V1 stuff is a good starting place if we say everything is implemented.
okay. Yeah.
That's all we're doing. After that, I foresee several years of having discussions with people who want individual features, where the features will drive this. Tony, did I miss something else?
Yeah, sorry. So I'm not productive. I'm bitching, but it's Friday. I'm allowed. So what we already seen, and Jeff is probably also aware of that. I think we had discussions. Is that if you push enough of that stuff, some of the hardware tables overrun. And we had this interesting problem that people would do different things then. And I think it would be good to define a predictable behavior, like purge, don't program anything, something. And I know it's difficult in BGP architecture, some notification saying I couldn't program this stuff. Because currently it's we're flying in the blind, right? And this is big. I mean, the F1 started already to run away size-wise. This will be big. So it will overrun hardware.
Yes. I mean, if you're going to do this, you might have to go to the bigger update packet in many ways.
Yeah, I'm not even going there. And then we can somehow cheat our way with, interesting NLRIs and I don't know, whatever RIDs. I'm concerned purely about that we got inconsistent hardware state. Right?
Again,
We didn't know
I
what it was.
agree that this is a big elephant. I can't do it theoretically. I've got to do it one one piece that someone's willing to say, I need this to go to market. And then we'll solve that, and we're grouping the people into two groups. Those who want to make new actions, those who want to make new filters, and we're going to work rules.
I'm with you, but architecturally, I think it needs a concept, okay? How you deal with the overflow consistently and some kind of a notification, some kind of way to figure out that things did not go well, okay?
Yeah,
So that's what and how it's solved in detail, like I say, I'm just having, free association session. Hey, it's Friday.
Again, we need to deal with it in real life scenarios. And then I've got to cut my own line as the chair. So Hayton, Philip, and then we'll just stop. And thank you all for dealing with this sort of, okay, where do we go next presentation.
Ketan Talaulikar, Cisco. I think the previous comment was some of these things are there in Flow Spec 1 as well. But here we are adding several capabilities, several options and all of that. Signaling this via capabilities, I think can become really complicated depending on how we do it. Using existing BGP capabilities, we'll probably need something very different to cover this. So BGP is a unidirectional protocol, and I'm really thinking now whether for something as complex as this, we will need to invent a SAFI in the other direction. I'm just worried
I
how this
agree.
is going to get utilized.
Jeff gave a proposal when we first started this for capabilities. I'm introducing a summary of what you all have, and I'm glad you come to the conclusion we need some sort of capabilities once we go beyond basic. Because the working group said no first, so, good.
Philippe Bergeron again. Yeah, so to me, starting with flow spec V1 match criteria plus ordering is great. And to get back on the comment.
I'm in a gear phone. I'm gonna lean over here. Go ahead.
Oh, sorry. And to get back on the comment on flow overrun, like this doesn't, like having too many entries, having too many of those in a given system. This doesn't change anything that FlowSpec V1 wasn't doing already. Like this is not changing any scale issue. Like so the problem existed before. The problem it is something else.
It is, for the basic, it is just changing one thing. Okay, we've got three other presentations for examples. We're going to try to go through those quickly. Just a minute.
Okay. Hello, everyone. I'm Nangong from Huawei Technology. I will introduce the draft of BGP flow spec for source address validation. Of course, I need to note that it's not an introduction of updates of this draft. I will show a use case of source address validation based on BGP flow spec and some discussion points in these slides. And of course, these points have not been updated to the draft. So I will update the draft maybe according to our discussion results after the meeting. Here is a use case of BGP flow spec for source address validation. And here is an example. We can generate sub rules on the controller or security center, and some sub rules can be distributed to the routers within the AS. Why we use BGP flow spec to distribute the sub rules? Because in some cases, the routers cannot get the complete set of sub rules. So we can distribute some complementary sub rules to the routers so as to enhance the accuracy of validation. And one of the advantages of using BGP flow spec is that we can reuse the existing some flow spec traffic handling actions. You know, there are many kinds of actions in flow spec, so we can reuse them to and apply them in the flow south right validation. And here are some discussion points. Okay. The first one is how to make good scalability is a scale problem. In the last presentation, Su also mentioned the group IDs and the prefix list. I think they are similar things. Here we can group source prefixes with different granularities. For example, we can use the orange AS number to group these source prefixes. We do not need to distribute all the prefixes in flow spec. And second, we can also group interfaces with different granularities. Actually, it's not new to group them in BGP flow spec. There are some graphs. For example, we can use orange AIs to represent a set of source prefixes. We can also use interface set to represent a set of interfaces. And the second discussion point is where do we put interface set in extended community or NLRI? In the kind of working group draft, in the interface set is put in the extended community. There are some pros and cons. And here, what I want to point out is that interface set can also be put in the NRI. The pro is in terms of meaning, interface set is more like a filter because it can determine which traffic do we take actions on, and in the open flow, the import is also considered as a match field. So there are similar things, but the cons are that interface set may have very local meaning, so there may be some problems in inter-domain flow spec cases. So another question may be, can interface set has a non-local meaning? So we have the third discussion point. Maybe we can use a flag to indicate whether the group identifier has a local meaning or a non-local meaning. An example of non-local meaning is that we can carry AS number in this identifier field, and the field will represent all the interfaces connected to this neighboring AS. So when the BGP messages with non-local meaning of group identifier is propagated to other ASs, the other ASs will can also recognize the meaning of group ID. And how do we verify the rules with only source and interface? So maybe we can only accept the flow spec rules with source prefixes originated from the same AS as the flow spec root, which is similar to another draft named BGP subnet. We have a use case here. A customer can proactively advertise some rules to its provider, and the provider can give some verifications to the customer's source prefixes. And the final discussion point is whether we can have a flag to indicate that the flow spec root is specific for SAV, and it can be installed in a SAV table. You know, in most cases, BGP flow spec are installed in ACL table or firewall table. They are not dedicated for source prefix filtering. So if we install too many source address validation rules in such tables, there will be a waste of resource in our hardware. And so if we want to use the BGP flow spec to support the SAV rule distribution, maybe we can use such a flag to indicate where to install SAV rules. It can be implicitly or explicitly. About the order, subrules are usually used to validate the packets after the BGP flow spec rules. For example, if we enable URPF in our routers, the packet will be checked firstly on the ACL table and then URPF and then maybe FIB. So about the order, we can put sub-rules behind the other BGP flow spec rules. Okay, next we'll update the draft according to our discussions, and thanks to for the comments from Jeff, Sue, and other participants. Welcome. Okay, thanks.
Thank you. Any direct comments here or online? Thank you, Non. It may be that it's Friday. Okay, Linda, I'm going to ask you if I can do your presentation with that. Okay, that may speed us up. I'm trying to catch us up. Yuzha, excuse me, let me get her slides up. This one you may be interested in because it is a flexible packet content filter. Welcome. What time is it there?
It's morning now.
It's morning. Okay.
Uh,
You should,
Thank you. Mhm.
you should, I will control the slides for you. Go ahead.
Okay, thank you. So I will start. And today I will introduce the packet content filter for the BGP flow spec. And next slide, please. Okay, so the first is the problem statement. With the scale of the DDoS attacks increase annually, a carrier network cannot defend well in face of some volumetric DDoS attacks. So, and then we found that there are some attacks have fixed content characteristics. As shown in the picture, is an ACK flood carpet bombing attack captured on the carrier network. This attack can reach more than 300 Gbps, affecting over 200 IP addresses and causing the service disruptions. In this situation, existing flow spec filter cannot match the traffic. Operators are also difficult to defend rapidly and effectively using cleaning devices or firewalls. Therefore, it's necessary to propose a new type of filter to implement the defense against this attack using BGP flow spec. Next, please. Okay, here is the packet content filter, and we also can call it payload filter. It has 6 fields in the value encoding. Next, please. We also gave a TLV encoding format for the flow spec v2 and defined the ordering of the rules. We have introduced it in the intern meeting. So if anyone interested, please find the draft. Okay, next. After discussing with vendors, we found the content matching requires high device performance, especially when the offset is large. So it's generally used with the firewall. To verify the effectiveness and the order of the rules, we build a testbed. The network topology is as shown in the slides. Business traffic and attack traffic were repeated based on real web access scenarios. It's based on the OpenBGPD and FR routing. We developed and deployed some new functions, such as new filter definition, flow spec announcement, send, receive, analyze, and traffic handling. People can find the related code from the GitHub project. Next, please. Here are the test results. We first test with several common network layer attacks, including UDP flood, SMP flood, and ACK flood, with different content characteristics. The blue line in the figure represents the traffic received by the web server, and the red line represents the traffic dropped by the router. It can be seen that with the packet content filter turned on, the attack is successfully filtered. Next, please. Then we test the filter on a HTTP flood with fingerprint. It's an application layer attack, and the traffic contains some TCP and HTTP packets. The filter can only match on HTTP GET request and TCP retransmission packets. The periods of peaks in the red line are the dropped TCP retransmission packets. The peaks in the blue line are the past TCP packets. Our filter can defend 25 to 55% attack traffic, and the remaining traffic needs to be defended with a cleaning device or firewalls. Next, please. We also conducted a set of tests to verify the ordering of the rules. The traffic is matched by two roles with different actions, and in some conflict situation, the order of the rules affects the final traffic handling result. And I will not explain it in detail because the time. Please refer to the slides. Next, please. It's the second situation. Next, please. It's the third situation. Next, please. Okay, overall, we did some development and testing work this time to prove the effectiveness of the filter. We hope to get more feedback, whether by the meeting or the analyst. Thank you.
Thank you. Any questions on her presentation and the data? Okay, I'm gonna, to try to help us hurry up, I'm going to try to tell you what I'd like you to pay attention to in the final one of the other ones. I asked each one of these to join us based on something that was in the slides. In this one, there is a filtering based on a UDP port. That's pretty normal. But when you, and here's the various UDP forms that should look like we see in FlowSpec v1. But what's happening here is a redirect to an IPsec tunnel. There were other previous proposals for redirect to an SR routing SID, which is effectively a tunnel. So you see that's one of the redirect features that we have here, and there are copies. And so there were 3 examples of some of the work I was showing. That concludes our FlowSpec educational moment. Again, the purpose behind this was to select a minimal subset of the FlowSpec v1 plus ordering as a beginning of adoption to go forward. That's where everyone implements. The rest we're going to have to work on together to get agreement. Please join those groups. With that, we're going to go on to the next presentation. And Anchor, it's yours.
Okay, we are back from features to a bug fix.
Yep.
Uh,
You just go to the right. It should be
Okay.
just right there.
All right. My name is Anchor Chen from Colado Networks, presenting on behalf of my co-author, Jenny Yuan. So this is, let's recap the problem. So this is it's really, it's basically the route selection in RIP and in BGP are currently basically the interaction, the algorithm route selection is uncoordinated or uncorrelated. In RIP, basically the everything route selection base path is based on this admin distance. And in BGP, it's based on the local path and ES path, right? Although in the end, BGP is downloading to RIP and RIP dictates which one will be the best path. But BGP has no idea about basically primary backup in the RIP. So when when you redistribute a backup rod, basically based on admin distance, when we talk about backup, in RIP, it's all about admin distance. When we redistribute the backup rod into BGP, depending on the ordering, the result would be different. Sometimes, basically, let's, for example, you redistribute a local static rod into BGP, the static rod becomes the best path in BGP. Sometimes something else. For example, the one you learned from eBGP becomes best path. Depending on the ordering, the timing, right? This so that's on one device. Then there are several cases also involving redistribution of the backup rod. In a network-wide, there are several cases, and the behavior is also non-deterministic. Depends on the ordering, the way that the local rod shows up in BGP first, or in RIP first, or the IPTP path shows up first. Certainly, this is undesirable. It's actually very frustrating. When I first experienced such a problem many years ago, it's very frustrating to see why it behaves this way. Sometimes this is the best path, sometimes the other best path. I would say non-deterministic behavior is worse, actually, than things not working completely, right? So this is a day one issue. It's a spot. It's basically it's a lack of, because the interaction is not specified. There's a lack of specification in BGP. And this issue exists in a number of implementations because of the lack of specification. Yeah, for customers and for the network operators, for people who are aware of this issue, or they are aware of this issue and the solution, or this draft, of course, they are go ahead, do the configuration. But there are still a lot of people who are not following, who don't really, who are not, expert with this level of detail. And from time to time, we still keep seeing these kind of reports. Say, oh, this is why this is not working. Then you have to explain to them, because here, when out of the box, it does not work. It's random, non-deterministic, right? It's really very frustrating when I first ran into this when I was a network operator. All right. What is the next one, right?
Oh, hold on. You should get it now.
Where should I point to?
No, it's me.
receiver?
It's me.
Oh.
Try it again.
Ah.
Is it working? Yes.
Okay.
That's me. I can't
so
move my
the-
pointer.
Here, let's recap the proposal, right? We basically, our goal is to make it deterministic, right? First, of course, it's basically on the single device. Basically, there are several ways to source a rod entry into the network, either through rod redistribution, or through aggregation, or through eBGP, right? There are three ways to source it. You source one, then you advertise to your network. First, let's make it that deterministic, because that we know for every one of them, one of this type, we know the admin distance in RIP. We can also propagate that into BGP, then we deterministically among these locally sourced rods, we deterministically select one. Okay, this is basically, so the proposal here is basically say, when I say with no admin distance, it really refers to these three types: locally redistribute, eBGP, and aggregates, right? Let's compare admin distance first before you do the local, right? How about within the network? We have several cases of non-deterministic behavior involving the right redistribution into BGP. So that's where in a network, admin distance is not there. It has to be local pref. So basically, when you redistribute the backup rod into BGP, and if admin distance is lower than the value for IBGP, we need to lower the local pref to make the behavior deterministic, right? So that, of course, there's a configuration option if people really know about this stuff, right? That's always there. But here, what we're trying to say is that, and basically, in our implementation, we can really make it automatic to cover the vast majority of the common cases. Okay, so what are the updates? I need to apologize to the working group for the delay in updating the draft. but it's better to be late than never. And so we have addressed the comments from the working group adoption. I believe it's 2 years ago, and I went back to the mailing list, and I think I will look at all of them. I also had a long discussion with Jeff. So thank you to the members of working group for your comments, and in particular for Jeff Haas. And we have extensive discussion. I think he pointed out two basically areas, ask us to basically to work on it. And one is basically, yeah, here if you look at it, there are basically there's two categories probably. One is the admin distance for locally sourced routes, right? That is, there's no change there. And I think it's the main revision about the simplification of the solution. Looks like we basically over-engineered the solution. Spend too much trying to make it generic to cover all the cases, primary, backup, tertiary, whatever. That does not seem to be necessary because most of the common cases, there's a primary, there's a backup. If somebody wants to use static routes, let's say redistributed static routes, for example, for backup, involve more than 2 paths, tertiary. They better know the details. They better know how to configure. Or they move on to BGP, right? So it's so our goal here for simplification, let's make the primary, the common cases work, primary backup case, and for the rest, either you require use more configuration to do, right? AC, do you?
I just have a quick one. AC Lindum Labin. So the basic problem here is that that static route is the backup route, and that has a lower default admin distance. But if you were to configure, which you're trying to avoid, the admin distance to be less preferred in BGP, it would all work, right?
Yeah. So
is that a yes or no?
Yeah, yes, that's correct. So
okay,
basically here, I think that there are a lot more people, in particular in enterprise, they know about admin distance. They say this is how you compare static routes with the BGP. They know all that, but they do know the interaction. So they say if I say that it's static route as BGP should take over, right, in all the cases. Why it only works, sometimes it does not. This ordering issue is difficult. So we try and basically say, okay, that's fine. In enterprise, you understand admin distance, we can take care of it. You make it behavior deterministic. Static routes, backup, you design a backup, it will remain as a backup. You both live at BGP. So that's the goal here.
Anchor, you've got about 1 minute.
I'm sorry. Let's focus. Go back to this.
You've got Jeff and Sasha.
Okay, let me finish. So first is the simplification. Okay, that we have done. I remove the stuff that they basically consider over-engineered. Okay. Second point is really about several people commenting and say, okay, here we are dealing with something that's already there in the field. Okay, we're trying to do bug fix. We have to make sure it's backward compatible. This is so you basically say the existing config. How do we make sure it's safe actually for you to say to adjust to lower the local prep to make it behavior deterministic? If you look at this in our current implementation, you have default parameter, default behavior. Then on top you have a configuration. That's it, right? Now, so what we are saying is this: you basically, to make it safe, make it backward compatible with configuration, you evaluate the config. If the config touches any of the parameters that impacts route selection, for example, local prep, AS path, MED, even origin, then you don't do it. You don't do anything because this guy already know what he's doing. Okay, right? Otherwise, this guy is safe.
We've hit the end of the time on a day that we don't have.
My comment. So in May, I also posted the reference design in FR. This is something I tested, covering both of the cases. Yeah, folks are welcome to look at. My intention is to basically work on upstreaming at some point. Yeah.
Okay, Jeff as one of the co-chairs, Jeff gets one comment. You got 1 minute, Jeff. Thanks.
Yes, less than 1 minute, hopefully. So Anchor, I haven't looked at the most current version of the document, but this is still putting implementation details into core BGP. No, there are implementations that don't have this problem. They don't have admin distance in the same way. Preference exists in like Juniper in a slightly different sense. So my comment still largely holds from last time. It's okay to document this as a set of practices for this type of implementation of distributed ribs, but I'm not sure that should be a normative practice for BGP as a whole.
So Jeff, I think regarding that, I don't think this is implementation because there's a lack of specification in BGP, right? This part of the behavior is not specified.
We don't have that problem.
Wait, and please, Jeff and you discuss this on the list because details matter, but
Yeah.
we've hit the end of our time. I apologize that we have that, but we need to go on to the next presentation. Okay,
All right, sure. Okay, thank you.
thank you. I'm
Yeah.
sorry.
Hello,
believe-
can you hear me?
Yes, we can. Go ahead.
Hello, this is Hang Shi from Huawei. I would like to introduce a simple extension to the BGP to carry the associated gateway exchange in the multi-segment SD-WAN. Next page, please. Yeah, first, the background on the multi-segment SD-WAN. At first, we have a kind of single hop SD-WAN as shown in the left. And it's basically an IPsec terminal to the existing VPN path. And BGP is used as a control plane to pass the attributes, the IPsec SA and port attributes. And in this draft, a new SD-WAN hybrid terminal type is introduced and a new SD-WAN SAFI. And for this hybrid terminal type, it has many sub-TLV to carry the port attribute, IPsec SA, that kind of stuff. And Microsoft proposes multi-segment SD-WAN. Its scenario is that sometimes the global internet path quality is not that good, so it uses a cloud backbone kind of as a multi-hop SD-WAN terminal. As you can see from the figure, the CPE1 to gateway 1 is segment 1, and the cloud backbone is segment 2 from the gateway 1 to the gateway 2, and the gateway 2 to the CPE2 is segment 3. So it's three segment of terminals get stitched together from the SD-WAN terminal from the CPE1 to the CPE2. And in the draft, they introduce the data plane change. They use the Geneva as the SD-WAN terminal, and a Geneva header extension is introduced. Basically, the data plane needs to carry the information about the destination CPE. That is the first sub-TLV called SD-WAN terminal endpoint, and the second sub-TLV is the source IP address of the source CPE, and the third is the IP address of the destination gateway. Next page, please. And since the data plane needs to carry the destination gateway information, this information needs to pass from the destination CPE to the source CPE. So we propose a simple extension to the BGP. And the process, it works like follows. First, the CPE2 will learn the address of the gateway 2 from config or any kind of discovery protocol. And the second, it will advertise the IP address of the gateway 2 through the BGP to the CPE1. So the CPE1 can put the gateway 2 information into the data plane. And to that end, we propose two simple extensions. The first extension is new NLRI, because this information is tied to a specific CPE, not a specific terminal endpoint. So basically, the key is to identify the CPE. And in this NLRI, the SD-WAN corner means the site ID, and the node ID is the IP address of the CPE. And the second is the new SE1 hybrid kernel sub-TLV to carry the associated gateway address. Gateway address is IPv4 or IPv6 address. So this is a simple extension, and we would like to hear your comments and suggestions. That's all. Thank you.
Any questions on this one? Well, thank you for the presentation. We may be tiring out toward the end of our Friday session. I'm going to pick up we have two more presentations. I will go through them quickly.
Hello. So can you hear me?
Yes, we can. You're loud and clear.
Okay. Hello, everyone. My name is Xie Chongfeng of China Telecom. It's my pleasure to give an update, present update on BGP extension, the procedure for IPv4, IPv6 mapping advertisement. Next, please. With the global deployment, IPv6 transition to IPv6 only has been an important trend. So this document defines BGP extensions, that is for MAP6, and the procedure for IPv4 service delivery in multi-domain IPv6 only other networks. This draft was proposed in January 2023 and adopted after IETF 118. Next, please. In multi-domain IPv6 network, the IPv4, IPv6 transition mapping rule is used by the ingress PE to generate destination address from the IPv4 destination address by stateless mapping. So this is scheme of for MAP6 mapping MPB extension, which is output of non-discussion within IDR working group, especially from the contributions of Jeff. Thank you. It has been present in last IETF meeting, so I do not repeat it again here. Next, please. So since IETF 119, the following revision have been made based on the suggestion of Su. The format of MAP6 tunnel TLV in section 3.2 is revised by changing the parameter of address origin type and forwarding type into two sub-TLVs. And moreover, utilization of the validation rule in FCA 9012 for the TLV and the sub-TLV in this case is added as well. Next, please. Next.
Just give me a minute. You should have it now.
Okay. In section 4.2, the behavior of ingress PE is updated by adding the checking the reachability of mapping prefix received in the IPv6 under the network to ensure its reachabilities. Yeah. So the section of ANA consideration is revised and moved to section 8, and we also made editorial changes. Next, please. So next step, we'll make the system implementations and do the working test, and the comments and suggestions will come, and further refinement will be made to improve the whole document. Yeah, this is it. So that's all.
Go ahead, Ketan.
Ketan Talalikar, Cisco. Could you please explain the relation of this BGP extensions versus the BGP extensions proposed in the draft that was just presented earlier today in Spring Working Group?
Yes, this is just about the corresponding function in the control layer. The document you mentioned is in Spring Working Group, right?
Yes, and I'm sorry, we don't need to do it now, but I have dropped an email on the Spring Working Group.
Yeah, I noticed
If you want,
your
we
mail.
could discuss on there, and I can copy IDR as well. If
Okay,
that's-
I will give you feedback. Thank you. In the
Thank
mail
you
list.
very much. Thank you.
Thank you, Ketan.
Any other comments online? Okay, we'll go on to the next presentation. Guyan, you have 5 minutes, so hit the most important thing on your changes. Thank you.
Okay. Yep, will do. Will do. Hi, can you hear me?
Yes, you're a little loud, but that's fine.
Okay. Hi, my name is Gian Mishra, and I'm presenting this draft on 4PE on behalf of co-authors. So I'm going to kind of cut to the main meat of it. So this draft, I've presented this draft a few times. We have a few updates to the draft, so we'll just go to the update page. So what I've done is I've cleaned up the verbiage, just made it a little bit more easier to read. I've added some terminology section that describes IPv6 only network. What I was doing, I was kind of referencing and creating too much, just making it overly wordy. So I've just cleaned up a lot of verbiage, and adding the terminology section really helped out a lot. And just really simplification throughout the draft, and then any like typographical or grammatical errors just clean up. So the draft definitely, I cut down, quite a bit in the draft. So I think now we're in good shape for an adoption. Jeffrey and Sue, if you get a chance, take a look. I think now, the draft looks a lot better than it was previous, before I did the update. So I think we should be in good shape. Thank you.
Okay, our next step for this will be to do a shepherd's review. Comments are always welcome. Thank you, Guyan, for the very quick and substantive update. With that, we will close IDR and let you hit to the goodbye celebration. Thank you very much.
Thank you.
Yes.